Just a little bit of background first on the anthropic principle and why it has gained so much importance and indeed popularity in the last 40 years, where before it really didn't have that popularity. Then the second area is to take a look at two popular explanations of why the anthropic principle, then this fine-tuning for life, why the anthropic principle might have worked. And these are naturalistic explanations, and they go by the name strong anthropic principle and weak anthropic principle. I want to take a look, though, the strong anthropic principle is a rather dubious one almost on the face of it, and we can discuss that in a moment. But it is the weak anthropic principle, which as a naturalistic argument has taken on a great deal of acceptance. But what I would like to say is it really shouldn't. And the reason that it shouldn't, by the way, a weak anthropic principle presumes a virtual infinity of so-called possible universes, which might have arisen out of the so-called quantum cosmological state in the Planck era of the universe, which is calculated by the summation over of the imaginary and real numbers over the sum of histories. And the key thing to look at here, though, are the odds of life still a virtual infinity to 1 for every possible universe that emerges? And the thesis of this paper is going to be, yes, there are 4 conditions which are required for a universe to give rise to a life form. And what I would like to suggest is no matter what kind of universe you start off with, you're still going to have these 4 things. And in order for those 4 things to produce life, you're going to wind up with a virtual infinity to 1. And you can keep postulating universes all day long, zillions of them. Not that I believe in any of them, but they're not significant. It's like the flip of a coin. And the thesis I will hold is, if the coin is honest, and you flipped heads 10 times in a row previously, what are the odds that you're going to flip heads again? 50-50. And if the odds of any possible universe arising are still being anthropic, arising are a virtual infinity to 1, even though you have an infinity of universes, in any given universe, what are the odds that universe is going to be anthropic? A virtual infinity to 1. And that's what's going to give rise in the end to what I'm going to call a dual faith. And we'll talk about what that dual faith means, but you don't escape faith if you know really physics and you know the equations which give rise to our universe, or any possible universe for that matter. That's the outline. What about the anthropic principle? As you probably know, the anthropic principle is kind of a statement of amazement. Because order in any given system is far more improbable than disorder, since the constituents which will lead to greater and greater degrees of complexity, which degrees of complexity will give rise to higher order activities, right? And that's key, higher order activities. We need those. Because if the complexity is just more goo and it doesn't do any more, this is not impressive. You can say, well, it's purple goo instead of red goo, but it doesn't do any more. That's not impressive. But if suddenly the complexity should suddenly go from an unsighted to a sighted thing, or from an unintelligent to an intelligent thing, and you say, wow, that's doing more. It's thinking. Then you say, that's rather impressive. But the odds of that kind of complexity, which does give rise to higher order activity, is always lower than configurations which just give rise to new manifestations of goo. In short, the odds of order giving rise to higher forms of activity are always lower than the odds of disorder or insignificantly ordered things. In other words, ordered things that don't do anything more. If that's the case, then an anthropic universe is indeed unusual. And of course it was thought up until the time of Newton because order, giving rise to higher forms of activity, is always lower than disorder. Of course, it was thought that somehow there might be some designing element that sort of loaded the dice, that made the highly improbable event of ordered complexes giving rise to higher order activities emerging by pure chance, right? That something, the pure chance part, well, it just, so somehow the dice got loaded. And when the dice got loaded, right, by this supposed intelligence, that would, of course, explain how we could get life forms and even intelligent life forms. But as you know, Newton came along and with the postulate that the universe was infinite in time and infinite in extent and of course, infinite in mass. And, well, all these infinities just they wreak havoc on your probability equations. I mean, what they wind up doing is making, in short, everything possible. I mean, if you have an infinite amount of mass and an infinite amount of space with an infinite amount of time to craft any configuration imaginable, well, it's not a short leap to say, well, maybe it could have happened. Even maybe a life form could have happened. And as you know, probably starting way back with Hubble's discoveries at Mount Palomar there, or a variety of other things, maybe dating back all the way to 1927 with the publication General Theory of Relativity by Albert Einstein, somehow the whole trend tended to change as one parameter after the next was introduced into the universe, finally getting to a very finite age of 12 to 15 billion years, with a finite volume, with a finite amount of mass, more or less, 10 to the 76 worth of number worth of hydrogen atoms worth of mass, and that's expressed in grams in a kilograms coming up in another viewfoil. But here's the point. Once you introduce finite parameters, once you introduce a finite amount of mass, once you introduce a finite amount of volume, and once you introduce a finite amount of time, you've got a real problem. Because then the probability functions become meaningful again. And all of a sudden you can actually calculate the amount of quantum perturbations in the entire universe for all time. Now, that, conservatively, liberally, 10 to the 200th, maybe, number worth of quantum perturbations for the entire universe for all time. Oh, be liberal. 10 to the 300th. I mean, let's just go out and say the universe is 100 billion years old. Skip the 12 to 15 billion. Just push all those numbers, right? And still, this is a really small number by comparison with the odds of what I'm going to call an anthropic universe developing by pure chance. So what happened then, and kind of in the history of things, is all of a sudden, with the finite parameters introduced into the universe by the Hubble numbers, by the general theory of relativity, by the discovery of by Penzias and Wilson of the 2.67 degree Kelvin uniformly distributed radiation. We always used to call it 2.7, but I think it's been recalculated. But the key thing, of course, is finite parameters got introduced. It changed the whole design argument entirely. The anthropic principle then comes on the scene, almost rushes on the scene, starting in about 1962. The literature then becomes prolific with this idea of how could, and here's the question, I'll explain it in a moment. How could the universal constants have the precise values that they have, the ones that give rise to life, and falling outside a very narrow range of those constants, they will not give rise to any complex life form whatsoever. None. Just in this very narrow range, which all of our universal constants just happen to have, they'll give rise to a complex life form. And people went, whoa, this is highly improbable. See, if you just take the standard 17 cosmological constants, that's the unit constants, that would be the constants of interrelation, that would also be the constants that are derivative, like the minimum Planck length and the minimum Planck time and so forth. If you just take those 17, and there probably are a few more if we really do have a uniform field out there, if you just take those and you think to yourself for just a moment, those constants could have had any value at all. And given the mass of the universe, let's just say about 10 to the 76 number worth of hydrogen atoms worth of mass, just around in that area, just take that amount and just kind of say, well, just with these gravitational constant, weak force constant, strong force constant, Hubble constant, cosmological constant, permittivity of free space constant, speed of light constant, just Planck's constant, push it just a little bit to the plus. Just push it to the minus, just a little bit. And you will have a universe that will either look like a black hole, or you will have a universe that disperses so rapidly nothing is ever going to collect into it, or you will have a universe that can never get together in any kind of atomic or subatomic complexity, or you'll have a universe, You'll have a universe which cannot accommodate, and here's the word, the complexity necessary for a life form. Skip carbon-based life forms. The complexity necessary for any life form. You're either going to have black holes, too much dispersion, or chaos. That's troublesome. So all of a sudden, what happens is, of course, the anthropic principle starts gaining a great deal of popularity after years of almost being poo-pooed, with the whole idea, well, the universe is probably infinite anyway, and so forth and so on. All of a sudden, we now have people taking seriously the fact that they have to have faith not to believe in an intelligent designer. In other words, the violation of the probability equations is so profound. In other words, notice that these constants could have had any value greater. That's a virtual infinity of values, or any value lower, right? But they have this narrow window which accommodates the amount of mass of the universe. Just so happens Planck's constant, gravitational constant, speed of light constant, Hubble constant, all have the right values. Could have had it any bigger, any smaller, but it doesn't. It has just the right values for our amount of mass in our universe to give rise to the complexity necessary for a life form. Whoa. I'll tell you what that probability coefficient is going to wind up being. Virtual infinity to 1. It's a virtual infinity to 1 with our amount of mass. And our unit charges of mass for protons, electrons, and neutrons. So the unit mass for proton, electron, and neutron, and unit charges of a proton, electron. The odds are a virtual infinity to 1 of a life form developing. No, of a universe which will allow the complexity necessary for a life form to develop. We are not even remotely close to life, just a universe which will accommodate complexity. And that became, of course, the faith of non-belief in a designer. In other words, if you want to believe that a virtual infinity to 1 universe occurred by pure chance, go right ahead, because it's okay. You can do it. It's highly improbable, virtual infinity to 1, but you can do it. But you do have faith. This has gone beyond reasonable and responsible belief. Now, the strong anthropic principle suddenly emerges as a counternaturalistic hypothesis, right? I mean, the minute the anthropic principle comes out as virtual infinity to 1, all of a sudden the strong anthropic principle is there, and here is basically how it goes, and really I'm not caricaturing it. The future event of life, which, by the way, has not yet occurred, and therefore I presume has not yet existed, that future event, not in a supernatural mind or any other kind of cosmic intelligence which might sort of hold it there as a design principle, but somehow the future event of intelligent life occurring sort of seeps back into the past. And somehow, as the universe is evolving, right at the Big Bang, right at the quantum cosmological Planck stage of the universe, suddenly kind of guided it or something. The anticipation of the future thing. Well, no, not anticipation, because there's no intelligence. And remember, the day not loaded by any intelligence. No, it's going to be an anticipation. But somehow, that future event affected the past one. And when it affected the past one, all of a sudden, of course, the universe decided to move in an anthropic direction. Now, I don't have to tell you, as John Polkinghorne would